Hey everybody, I decided I'm going to kind of answer an email while I'm letting a bunch of Gorilla Glue. I'm actually gluing in the hard points on my wings, so when I slide them onto the wing tubes, I put some 832 button head screws in that hold my wings onto the center section, my outboard wings. But I got an email and somebody asked me, how is it that I conceal my control arms on my flying surfaces on some of my airplanes, and on other ones why I don't. So I would say most of my airplanes, if they are scale, I will try to hide the control arms and control linkage to like the elevator and ailerons and rudder. If it's something like this, I don't care they're exposed. But I do want to explain some of the different ways I've done it, and hopefully you can see this pretty well here. So let's first talk about a conventional rudder. And this is like, we're looking down, and here's your rudder. And you probably want a hinge point right about here in the center, if possible, so that when it moves, this gap isn't getting bigger and smaller. So I normally will design a hinge that comes out like this into the rudder so that the rudder pivots on that point. Now I just need to figure out how far out do I need to go from this pivot point to have enough mechanical advantage to make sure the servo's got enough torque to move the rudder. Now, if it's like an aerobatic airplane, I would just bring two horns out and run cables back into the fuselage to the servo. So when the servo moves, it moves my rudder. But let's say you want to hide that. Let's say that you don't want that exposed. So how would you go about hiding that? And the way I do it, and you got to be careful here, because some people don't realize if you can't balance this rudder, which means put some weight in the very front right here so that it's kind of statically balanced, it can flutter. The smaller your gap here is, the better it is, and it won't flutter. Another thing you can do is, if your rudder is shaped like this, and here's your hinge point, and let's say this is the back of your vertical stabilizer, so you're looking down, I've brought very thin 64th plywood out here so that when this pivots, this gap stays the same, and that is almost sealing the gap on that rudder, okay? So, but let's talk about the control arm. If you come out far enough in here and leave a groove, so if you're looking at the rudder and you have a groove in it for the hinge, and this is the pivot point, okay, you're looking at the rudder like this. This is your rudder. You'd have a hinge here and a hinge here. But you know that this hinge point is inside here. So you got to leave a little bit of a groove. I drew that wrong. You got to leave a little bit of a groove so that when that rudder pivots, it's not hitting that hinge. Okay? So what you want to do is, you know you have a groove in here so that the hinge fits in here. But right above where that hinge would be, I would create another groove only on one side and put a pivot point right here so that an arm could be connected to a servo somewhere in the tail, and it's pushing on that. Now you could do a push-pull here, and it depends on the scale of your airplane. Now if it's a really small airplane, you might have to use a really small high-torque servo to make it work. But that's how I hide right there my control linkages inside it. Now, there are other ways to do this. If you've got an airplane like where the fuselage is this, and this is your rudder, you could make this a torque tube and go down in here and put a servo in here and have it hooked up to that torque tube so that it's buried inside the fuselage here. But if you've got an airplane where the back of the vertical stabilizer is like this at the back of the airplane and your rudder goes all the way down to the bottom of the fuselage, then you've got to figure out, okay, how am I going to make that work without the control arm showing? I personally don't care if a control arm shows. There's certain airplanes like my MSL-2 that the ailerons, I kind of buried them in because keep in mind the aileron was 3 inches thick at the hinge. So I had plenty of room to do this kind of a setup. The most important thing that you can keep in mind is the slop. How much slop am I going to get out of this system? If your hinge is not absolutely tight, and I'm talking pressed in tight, the amount of torque it takes to push, the amount of torque servo it takes to push this little bit of a mechanical advantage here. And actually, let me explode that for you. So think about, in the name of scale, okay, in the name of scale, you are trying to bury something inside a surface so you can't visually see it. If you look at real airplanes, full-scale airplanes, not real airplanes, full-scale, you can look at where the control arms are, and many times they'll come down almost to the surface. So let's draw this real big here. Okay, so this is your whatever. Could be an aileron, could be a rudder. Here's your pivot point. Here's the back of the whatever the flying surface is. Let's say you do bring back and close the hinge gap. Whatever this distance to this distance is here, okay, that is going to be your mechanical advantage, your lever arm to move this flying surface. So if this is only a half of an inch because of the size of your airplane, okay, so let's say this is 0.5 inches. And over here you've got, I don't know, 0.75 for your servo arm, okay? Any slop in this hinge right here, and I mean any slop in your servo, if you got a cheap servo that you can actually grab the arm and move, this thing is going to move all over the place. Now, if there's some balance weight in the front of this, you should be able to unhook that surface and fly real fast and it would never flutter. But most of us can't add that kind of a weight because we actually build our flying surfaces heavy for the scale they are. So what you really need to think about here is, how do I get this mechanical advantage to really make this flying surface work? On small, like 60 size and smaller airplanes, it's really, really difficult. Unless you're going to make this a torque tube and run it down inside something. On ailerons, sometimes you can run that torque tube all the way into the fuselage, and when you plug your wing in, you're picking up that torque tube. If you got flaps, that might get in the way. But this right here, this, if you have slop in this, I mean, I tell you, I have probably built 50 airplanes in my life that when I did this, the slop was horrible. I mean, it really drove me nuts. I have built airplanes where I had a control arm out here, okay? And it went to a servo with a big old long arm. But the servo was cheap. It didn't have a really good bearing system. So when I would move this, that arm would move probably 2 millimeters. Now, chances are that 2 millimeters will not cause flutter because most of my airplanes are not made to go really, really fast. And I also balance my ailerons on them. The MSL-2 is the only airplane I built because it flies so slow that I have not balanced the ailerons or the elevator. The rudder has a little bit, but the elevators aren't balanced and the ailerons aren't balanced. But keep in mind, I'm using like $300 servos or $280 servos that have zero slop, and they're really high torque, like 400 ounces. So, but I want you all to kind of think about, if you really truly want to build scale and bury that, there is a lot going on that you need to think about. I mean, there is a whole lot going on because you essentially, the biggest weakness I have found are in hinges. It's really hard to take a Dubrow type hinge. You know, you got a hinge. Hang on a minute, is that getting into the glare? Yeah, let me draw it down here. So here's your flying surface. Here's your hinge. Here's your horizontal stabilizer or rudder. Vertical stabilizer. This is either your elevator or your rudder. And a lot of times you'll have your hinge right here. And with the Dubrow hinge, you push it into the hole and glue it. So there's your pivot point. If you want your pivot point to be in here, most hinges don't even get into the flying surface. That's the reason I make all my own hinges. Because I want most of my hinges look like this, and then I have some holes so that glue can get soaked in there. And I make these out of aluminum. That way, there's my flying surface. Okay, I'm trying to make sure I'm not getting into the glare, guys, because there's a bunch of glare in this garage I can't get rid of. And without this falling over. So that's essentially what I wanted to address. I got an email about it. I've gotten several emails on this big airplane asking about how some of the stuff works. The leading edge devices are probably one of the most exciting things I've put on an airplane because they work really good. And I had a lot of design time that went into those leading edge devices. So, but I hope this helps people understand kind of the complexities if you're wanting to bury those control arms so you can't see them. There is a design out there that somebody did, and I don't want to draw it because I don't want to knock it, because I've never done it. One thing you'll never see me do is knock something I haven't done. But keep in mind, if you have a lever arm, and you basically have a lever arm here inside your control surface, okay? The bigger this lever, the less slop you're going to have. The bigger this lever and the smaller this lever, the more torque it takes. The smaller this lever and the bigger this lever, it takes a lot less torque to move it. And, okay, here. Hey, Emma, you can go out the garage. So, daughter's got to go to Staples. She's trying to see Albert Einstein. So, hopefully all of this makes sense. Uh-oh, let's see what the camera does when it gets real bright. Hey, close the garage door once you get in your car. So, hey, this camera's not doing bad. I tell you guys, for a cheap HD camera, even though outside looks like it's 5,000 foot candles. But I hope this makes sense with these levers and everything, okay? And then you've got the trade-off on how much throw you want. So if you want a little bit of throw and a lot of torque, that's easy to get. If you want a lot of throw and a lot of torque, you just need a lot of servo to do that. So, and then I don't want to get into the whole thing about how much throws you really need. If you're doing 3D, that's something totally different. Okay, if you're doing a scale airplane or a warbird, most people, this is what's amazing here, okay? And remember what I'm going to say here. And I'm trying to say this politically correct. Most people will put way too long of throws on their elevators, but nowhere near enough throw on the rudder. I don't know if they're scared of snap rolling. I don't know what it is, especially on multi-engine warbirds. I have seen so many multi-engine warbirds have like 20 degrees of rudder, and if you really ever had a motor fail on a model airplane, that 20 degrees ain't going to do crap for you. So look at the real full-scale airplane and see what the travel was on the rudders. Most of the time it's 35 degrees. Some of them have been 40 degrees. I have seen scale gas banger B-17s crash because of one of the engines failing. And you see a little bit of rudder. There was a big B-29 crashed one time. And when you watch the big B-29 crash, you see how much rudder was in it, and the rudder looked like 15 degrees. If that rudder would have had 40 degrees input, that probably would have been enough to keep that plane flying somewhat straight. So keep in mind, everybody, you probably want 25 to 30 degrees on your elevators. On your rudders, you want as much as you can get before it aerodynamically stalls that rudder, which is like 40 degrees. And then you got to figure out how you're going to get enough torque to move it, which is money. That's a shitty part of RC airplanes. If you want high torque in a servo that is really quality built, you're spending $200 to $300 on a servo. Now, I know I'm going to get some hate email by saying that, because I know there's some high-tech, high-torque servos that are really, really good, and I totally agree. I totally agree with that. But some of the servos I buy that have telemetry in them are close to $300 servos. So everybody have an awesome day. I hope this helps answer everything, and everybody rock on. And keep the emails coming. I'll try to get them answered. I'm actually taking a vacation day today. It's Friday, and I'm going to get a boatload done on my airplane, and maybe make a couple more videos answering some emails. Rock on, everybody. Have an awesome day. Take care. Yep, it's working. Hang on. I just didn't see my red light going. I'm like, oh my God, did I just talk for 20 minutes and nothing happened? I probably should take this out at the end, but it's kind of a funny blooper, isn't it? Rock on, everybody.